In this video, we are going to discuss about matrix, which is nothing other than a two-dimensional array. In the previous video, we have discussed a normal array which just has one index. But this time, we are focusing on two-dimensional array or 2D array, which has two different indexes. Why two different indexes? You can consider a two-dimensional array or a matrix just like a table, as you can see in this left-hand side of the slide. In a table or the tabular form of data, there are two different things. One is the row, which is incrementing like this, and then for each row there is a set of columns which is like this. So row is incrementing from 0, 1, 2 like this, and for each row there is a set of column indexes which are 0, 1, 2, 3 like this way. Now whenever you want to identify an element in the matrix, you have to use these two different indexes. In an array, since it had one dimension, you could just use something like array 1 and then the index, or let's say this index. That's it, and some values inside it. So only one index. But when it comes to matrix, and since the matrix has both row indexes and column indexes, you have to use two different indexes like this way. This, let's call it matrix instead of array. So here, and instead of one index, there should be two different index, and there should be some kind of values here. So what is the meaning of these two different index? The first one basically indicates the row. Let's say I want to, and the second one actually identify the column indexes. Let us try to clarify with a simple example. Let us say I want to identify this element 5. What can I say? This is appearing in the matrix where at row 0 and column 0. So you have to write 0 and 0 here. Next is, let's say I want to identify or access this element 100. So what can I say? That this 100 is actually appearing in where row number 1, as you can see. So row 1, and which column? It is column number 2. So column number 2, this element is 100. So in this way you have to identify each element in a matrix. There are two different indexes, one for row index and another for column index. Now let us look at the code, how you can actually declare and initialize a matrix. The exact syntax you can see in this part of the slide. So just like an array, first you have to define the data type of the matrix. That is, what type of data element you are going to store in it. As you can see in our matrix, we are storing all the whole numbers like 5, 9, 22, 6, 35, 100, 2, all are whole numbers. So that's why I have used int. But it depends on the problem description. It can hold any type of data like character, double, etc. And based on that, you have to change this data type to either character or double or something like that. After that, you have to specify two different set of opening and closing box bracket. Remember the array. In array, since it has only one index, we have specified only one set of opening and closing box bracket. But this time, since it has both rows and columns, it has two different types of indexes, we are giving two different set of opening and closing box bracket. The first set of opening and closing box bracket is actually the row indexes, and the second box bracket is actually giving me the column indexes, like that. After specifying these two different sets of opening and closing box bracket, you have to specify the name of the matrix variable. Here I have chosen matrix1 as the variable name. After this declaration, now it is the time to initialize or populate the matrix with some real data element. In order to do that, first, of course, you have to use this assignment operator, which is basically saying that, well, now I am ready to initialize some or populate the matrix with some variable. After this assignment operator, you have to use this new keyword just like a single dimensional array or a normal array. This is how you are telling the Java compiler that, well, now I am ready to initialize a two-dimensional matrix. And after that, once again, you have to specify that int followed by two sets of opening and closing box bracket. So this entire thing is basically saying that, well, now I am ready to initialize an entirely brand new integer type of matrix or integer type of two-dimensional array. After that, you have to write everything inside an opening and closing curly brace, just like an array. So everything you are writing inside an opening and closing curly brace, as you can see in here. But this time, remember, it has two different things, rows and columns. So this first set of, or this outer set of opening and closing curly brace, basically providing you the container space for the entire matrix. So this is what is the meaning of the outer set of opening and closing curly brace. Now inside the entire matrix, what do you have? You basically has lots of some set of rows, right? So for example, you have row 0, row 1, row 2, like this. So now it's the time to put the values in each different rows. Now when you are putting elements inside each different row, considered it just like a single dimensional array. Like each row is actually a single dimensional or normal array. So what do you need to do? You have to put all the elements inside one row inside another opening and closing curly brace. So the first set of opening and closing curly brace, or let's say first set of inner opening and closing curly brace, it is basically giving you row 0, the container space for the row 0. And next, let's say the next set of opening and closing curly brace, which is this one, it is giving you the space for row 1. The next set of inner opening and closing curly brace is giving you the space for row 2, like this. And inside each row, now you can put all the elements that you want to store inside the matrix. Just see, in the first row, or let's say a row 0, I want to put 5, 9, 22 and 6, as you can see in the table. So let us write 5, 9, 22 and 6, and all these elements should be separated by a comma, just like a single dimensional array. Then in the second row, or let's call it row 1, starting the count from 0, in row 1 we have 6, 35, 100 and 2. So let's write down 6, 35, 100 and 2. Everything is separated by a comma. And in the third row I have 1, then 82, then 70, and then 769. So write down then 1, 82, 70, and 769, everything separated by a comma once again. Now, since this is a matrix, every row also should be separated from each other with a comma, as you can see in here. So after finishing the assignment of the variable in row 1, after this closing curly brace of row 1 corresponding to row 1, you have to put a comma. To separate for row 0, you have to put a comma, just as you can see in here. Then for after the end of the set of opening and closing curly brace of row 1, you have to put another comma to separate it from other row. So that means each row should also be separated with a comma. And in the last row, you really do not need to use a comma because this is the end. So two things. Since there are two different indexes, you have to just replicate everything for the inner dimension also. The first dimension, the first set of opening and closing curly brace is giving you the entire matrix, and then each of the inner set of opening and closing curly brace correspond to one row, and each element in the row should be separated by a comma. Not only that, each row should also be separated from each other by a comma.